Hello. Let's start the chapter 4 practice test solution key. We'll start with the first question. Given that theta is 210 degrees, find the coordinates of P of theta on the unit circle. Well, we can attempt this question on a multiple spectrum, but perhaps we can try to draw this angle on the unit circle first. First of all, the angle theta of 210 degrees, it can be represented as 180 degrees plus 30 degrees, which means that this angle must be in the quadrant 3 with the reference angle of 30 degrees, like this. So we know that information. Um, also we can try to use the special triangle with the angle 30 degrees, given that the hypotenuse is 2, the opposite is 1, and the adjacent is square root 3. I can then redraw this triangle, a similar triangle with different length, for the hypotenuse to be 1, opposite to be 1 over 2, and adjacent to be square root 3 over 2. Therefore, we can find the coordinates of P of theta, x and y coordinates, which is given as cosine theta, comma sine theta. Cosine theta, or cosine of 30 degrees, is adjacent of hypotenuse, so it'll be square root 3 over 2. Sine theta will be opposite of hypotenuse, so it'll be 1 over 2 over 1, so 1 over 2. Now, we're in quadrant 3, which means that both x and y coordinates must be negative. So my coordinates of the angle 210 degrees will be negative square root 3 over 2, comma negative 1 over 2. Looking at part B, find the coterminal angles of theta find for the domain of negative 360 degrees to 720 degrees. Well, first of all, I can find the coterminal angle of 210 degrees simply by adding 360 degrees times n. Now, because of the domain going from negative 360 to positive 720, I can think of that starting from 210 degrees, the starting point, I can go minus 360 once, which is going to be negative 150 degrees. And I can go up as plus 360 degrees, which is going to be 570 degrees. I can try to go one step further, and then we'll see what happens to it. Negative 150 minus 360 one more time would be negative 510 degrees. If I go one step after 570, it'll be 930 degrees. However, given the domain, restriction of the domain, my theta can only go as low as negative 360 degrees, and it can only go as high as 730 degrees. So we know that negative 510 degrees and 930 degrees will not be allowed. So therefore, the correct answers are negative 150 degrees, 210 degrees, and 570. Let's try the question number 2. Given that the x-coordinate of a point A in quadrant 3 on the unit circle is negative square root 3 over 2, find the y-coordinate. Well, first of all, we can use the equation of the unit circle, which is given as x squared plus y squared equals 1. So let's plug in the fact that x is negative square root 3 over 2. While we're doing this question, we can also remind ourselves that when you see the number square root 3 over 2, it's strongly, highly related to the number 1 over 2 as well. So I think that's going to be my answer, but for the sake of practice, let's just continue with my journey as it is. Although it's necessary to put plus minus sign at this point, because it's given that my point A is in quadrant 3, my y value must be negative. So therefore, my y value will be negative 1 over 2. Part B, let's find the angle and standard position. Well, we can try to draw this situation as well. And also, as I said before, from my memory, the number square root 3 over 2, number 1 over 2, for me sounds kind of like um, multiple of pi over 6. That's my intuition, but we'll try to draw it out to solve this question. So let's draw the unit circle. And apparently the coordinates are negative square root 3 over 2 and negative 1 over 2. So it must be somewhere like here in quadrant 3, where the adjacent x value is negative square root 3 over 2, and the y value is negative 1 over 2. For me, that seems like that has a reference angle of pi over 6. So my angle in standard position must be quadrant 3, remember that it's pi plus reference angle, which is going to be pi plus pi over 6, which final answer will be 7 pi over 6. Let's see. Another point B has the coordinates square root 2 over 2 comma negative 1 over negative square root 2 over 2. So let's start by plotting that point as well. I'll draw another unit circle. So my previous point was A, was at that point, and my other point, B, positive x value, negative y value for me sounds like we're in quadrant 4, and square root 2 over 2, negative square root 2 over 2 for me sounds like the angle must be some kind of multiple of pi over 4. So the question wants me to find the arc length from A to B. Well, the arc length can be found by doing the r theta, where theta is in radians. So I need to first find the angle between A and B. Well, I know from the previous question that this reference angle is pi over 6, and I know that this angle has to be a reference angle of pi over 4 as well, which leaves a pretty neat equation. A neat equation. The entire bottom side will be half a rotation, so that's pi, right? So theta must be pi minus pi over 6 minus pi over 4. So that will leave out the remaining section. Will be pi minus pi over 6 minus pi over 4. So that must be, well, I need to first find the common denominator, which is going to be 12. So let's say 12 pi over 12 minus 2 pi over 12 minus 3 pi over 12, which must be 12 minus 2, 10, 10 minus 3, 7, 7 pi over 12. If I know that the angle is 7 pi over 12, I can plug into the formula once again. L equals r theta. Well, r is just 1 because it's a unit circle. Theta is 7 pi over 12. So my arc length must be just 7 pi over 12. Let's try the next question. Solve the following equations. Well, all these equations, I'm pretty sure we've solved multiple of them repeatedly. So let's give it a try. Part A, 2 cos theta equals cos theta plus 1 over 2. Let's start by substituting that u is equal to cosine theta, which then my equation becomes 2u equals u plus 1 over 2. If I solve for u, it becomes u is equal to 1 over 2. Pretty neat. U is cos theta, so let's replace it back with cosine theta. Then, at this point, I don't want to solve cosine of theta equals to 1 over 2 right away. What I want to do is I want to replace it with cosine of r, theta with r, and positive on the right hand side. Well, it's already positive, so I don't need to do anything. Now let's solve for let's solve for cosine of r is equal to 1 over 2. How can I do that? Well, for this one, I think I can use um, the right triangle, or special triangle. Cosine means adjacent over hypotenuse, so let's draw a triangle where the adjacent is 1 and the hypotenuse is 2. For me, that sounds like a special triangle with the angle of 60 degrees. For this one, I can go 60 degrees because the given domain is represented in degrees. So I know that reference angle is 60 degrees. I also know that because my cosine theta is positive, I know that my angle must be in quadrant 1 and quadrant 4, following the ASTC abbreviation. So let's find the quadrant 1 angle and quadrant 4 angle with the given reference angle of 60 degrees. In quadrant 1, theta is r itself, so I think it'll be the 60 degrees. In quadrant 4, the angle in center position will be 360 minus 60 degrees. So my angle and center position will be 60 degrees and 300 degrees. So therefore I know that my angle must be 60 degrees or 300 degrees. Now I need to check the coterminal angles of these. So the first one will be 60 degrees plus 360n, and the second one will be 300 plus 360n. However, given the restriction of the domain is going from 0 to 360 degrees, which means that it's just going for the one rotation. So I know that if I go 60 plus 360 or minus 360, it'll be out of the range, and same thing for 300. So my final answer is just simply 60 degrees and 300 degrees. By the way, we can always check our answer by using a calculator. We can use the calculator to compute cosine of 60 degrees and see that we do get 1 over 2. And same thing for cosine of 300 degrees. Part B. Well, this question involves some kind of cosecant x, which no one likes. So I can see in the near future, I'm going to replace that with another ratio. So let's give it a try first. First thing it's going to do, I'm going to replace that u be cosecant x. So it's going to be 3 equals square root 3 u plus 5. Let's solve this equation step by step. Minus 5 on both sides. Negative 2 um, equals square root 3 u. So it's going to be negative 2 over square root 3 is equal to u. Let's just rewrite u on the left hand side and negative 2 over square root 3 on the right hand side. U is replaced with cosecant x. Now I realize that I don't really like this formation, do I? Because I don't like cosecant x. No one likes cosecant x. So I'm going to replace cosecant x with 1 over sine x. Then we can quickly see that my sine of x will be reciprocal of negative 2 over square root 3. It's going to be negative square root 3 over 2. Now we do the same thing as before. We replace x with r, and we replace negative number with a positive number. Once again, at this point, let's solve this equation using a special triangle. I want to draw a triangle where the opposite is square root 3 and the hypotenuse is 2. Well, isn't that the same triangle as before? The opposite of square root 3, the hypotenuse is 2. This reference angle is also 60 degrees or pi over 3. This time I have to go with pi over 3 because domain is given in negative 2 pi to 2 pi in radians. So once again, we solve that r is equal to pi over 3. And this time, my sine is negative. My sine is negative, which means that my quadrants will be in quadrant 3 and quadrant 4, also following the same ASTC abbreviation. So let's find the angles in quadrant 3 and quadrant 4. In quadrant 3, the angle is theta is equal to, sorry, theta is equal to uh, pi plus r, which is going to be pi plus pi over 3, which is 4 pi over 3. In quadrant 4, the angle is 2 pi minus r, which means it's 2 pi minus pi over 3. If you do the math in your head, 2 pi is 6 pi over 3. 6 pi minus pi over 3 will be 5 pi over 3. So my answers are theta is equal to 4 pi over 3 and 5 pi over 3. For this one, I'll skip some steps and add 2 pi n at this point. Now this time I need to actually consider some different angles because I know that my domain is going from negative 2 pi to 2 pi. So let's list out some possible numbers for my angle. For 4 pi over 3, if I add 2 pi, it's going to be you had 6 pi over 3, so it's going to be 10 pi over 3. If I just subtract by 6 pi over 3, it's going to be negative 2 pi over 3. You can try one more time and say negative 8 pi over 3 is also possible. For 5 pi over 3, there's something similar, adding by 6 pi over 3, so 11 pi over 3 on the positive side. If I subtract by 6 pi over 3, it's going to be negative pi over 3. If I subtract it one more time, it's going to be negative 7 pi over 3. Once again, all these numbers do work. However, we just need to select the ones that do fit in the domain. According to the restriction of domain, my x value must be between negative 2 pi and positive 2 pi, which means that I have to exclude the negative 8 pi over 3 and negative 7 pi over 3 because they're less than negative 2 pi over 3. Also, 10 pi over 3 and 11 pi over 3 are greater than 2 pi, which means I have to exclude them. So my final answers are only negative 2 pi over 3, negative pi over 3, 4 pi over 3, and 5 pi over 3. We're doing a practice test, so don't bother. Excuse me? Excuse me? Let's move on to the next question. Once again, same questions, same equations, but things are slightly more complicated, so let's give it a try. Part A. 2 tangent of x plus 1 is equal to 5 tangent of x plus 4. Well, once again, let u be tangent of x, which is going to be 2u plus 1 equals 5u plus 4. Solving for u, let's go negative 3u is equal to 3, u is equal to negative 1. Tangent of x is equal to negative 1. Now, let's replace this, once again, with tangent of r is equal to positive. Now, we need to draw a special triangle where tangent is opposite of adjacent, so opposite is 1, adjacent is 1. Well, we do know that triangle as a special triangle, right? Opposite is 1, adjacent is 1. This is the angle, triangle where the angle is pi over 4, using radians. 45 degrees, pi over 4. So we know that r is equal to pi over 4. This time, tangent of x is negative 1, which means that my quadrants must be in quadrant 2 and 4, or negative tangent. Same thing. In quadrant 2, the angle is pi minus r, which is going to be 3 pi over 4. In quadrant 4, theta is 2 pi minus r, which is going to be 7 pi over 4. For these two ones, we need to find the general term as well, plus 2 pi n, plus 2 pi n. So the domain is restricted from 0 to 4 pi, so it's just the same thing. Starting 3 pi over 4 and 7 pi over 4. Let's add and subtract by 2 pi's. If I add 2 pi to a 3 pi over 4, it's going to be, to do 2 pi is 8 pi over 4, so it's going to be 11 pi over 4, 19 pi over 4. If I subtract 8 pi, it's going to be negative 5 pi over 4. Same thing with 7 pi over 4. Let's add by 8 and subtract by 8. If I add by 8, it's going to be 15 pi over 4, Multiply that by 8 one more time, 23 pi over 4. Subtract by 8, negative pi over 4, and so on. Once again, my domain restriction is going from 0 to 4 pi. So out of the bat, I can disregard the negative values. And my highest value for my theta is positive 4 pi. So 11 pi over 4, 15 pi over 4 are good, but 19 pi over 4, 23 pi over 4, not in the answer. So my final answer will be 3 pi over 4, 7 pi over 4, 11 pi over 4, and 15 pi over 4. Next question. Sine squared of x plus 0.5 sine of x is equal to 0. For this one, it looks complicated. So once again, let's do some substitution once again. Let u be the sine of x. If I replace u with, if I replace sine of x with u, my equation becomes u squared plus 0.5 u equals 0. Now, this is a quadratic equation, and for me, there are multiple ways to solve the quadratic equation, but for this one, I think factoring could be the best and easiest method. So let's use factoring. U times u plus 0.5 is equal to 0. What does that mean? Well, this means that u can be 0 and u can be negative 0.5. It's either or. So in this case, if I replace sine of x back in the place of u, it becomes sine of x is equal to 0, sine of x is equal to negative 0.5. So I need to solve multiple equations now. Let's first solve sine of x is equal to 0. Remember that I told you in class that if you have sine of x or cosine of x is equal to 0 or plus minus 1, drawing the special triangle becomes kind of weird. In my opinion, this one is better solved using the unit circle. Drawing the unit circle, knowing that my sine of x represents the y coordinates of the unit circle, solving sine of x is equal to 0 is similar to finding where my y coordinate is equal to 0. I think that's pretty simple. My y coordinate is 0 at these two positions, the x-intercepts. So I can quickly tell that at my x value will be either 0 degrees, or 0 radians, or pi radians. Because it's either at the 0 rotation or half rotation. That was easy. Let's try the same thing for the second case. Replace x with r, replace negative 0.5 with positive 0.5 or 1 over 2. Reference angle of sine of 1 over 2. Sine is opposite of hypotenuse, so let's draw a triangle. The opposite is 1, hypotenuse is 2. I've seen this multiple times. This angle is pi over 6. R is pi over 6, but my sine of x was negative, so that means that we need to go in quadrant 3 and quadrant 4. So theta, in quadrant 3, theta is equal to, or x is equal to, pi plus pi over 6 will be 7 pi over 6. In quadrant 4, x is 2 pi minus pi over 6, which is 11 pi over 6. Now, the domain of this question was 0 to 2 pi, which is just within the one rotation. So I don't think I'll have to do the coterminal angles for this one. So my final answer is x could be 0, 7 pi over 6, pi, 11 pi over 6. The order is kind of weird. So 0, pi, 7 pi over 6, and 11 pi over 6 will be my final answer. Once again, you can plug all these values into the original equation to show that these answers are correct. Just like how you used to check your answers by plugging in the value when you solved a linear equation back in grade 8. Final question. This is kind of a kick, in my opinion, for this question. So let's give it a try. 3 cosine of theta minus 2 is equal to secant theta minus 4. So in this case, I have a cosine appearing and I have a secant appearing. Well, first of all, I don't like the fact that I have two different trig expressions. And also, I don't like the fact that I have a secant theta. So let's first get rid of the secant theta first. I know that from the formula sheet that secant theta can be replaced with 1 over cosine theta. And then my next thought process is, I don't like having fractions in my expression. I don't like having fractions in my equations. So therefore, I'm going to multiply both sides by cosine of theta, which then I get 3 cosine squared of theta minus 2 cosine theta is equal to 1 minus 4 cosine of theta. I said I multiply both sides by cosine of theta. Now let's collect like terms. 3 cosine squared theta plus 2 cosine theta minus 1 is equal to 0. Now at this point, again, we have one trig expression, so let's use a substitution. Let u be cosine of theta. Now let's replace 3u squared plus 2u minus 1 is equal to 0. Now let's solve this equation. Well, why not solve this equation? I can use the quadratic formula, knowing that u can be solved by doing negative b plus minus square root of b squared minus 4ac divided by 2a. U is equal to negative 2 plus minus 2 squared minus 4 times 3 times negative 1 divided by 2 times 3. U is negative 2 plus minus 4 plus 12, which is going to be 16. Alright. Solving on that nicely. U is equal to negative 2 plus minus 4 over 6. So U is either going to be negative 2 plus 4, negative positive 2, so positive 2 over 6, 1 over 3. Or U is equal to negative 2 minus 4, which is negative 2, negative 6. Negative 6 over 6 is negative 1. So at this point, I can either solve cosine of theta is equal to 1 over 3, or cosine of theta is equal to negative 1. Let's bring this up here again. Cosine theta is equal to 1 over 3, or cosine theta is equal to negative 1. Let's prove that the cosine theta is equal to negative 1 first. The fact that cosine theta is equal to negative 1, well, remember that's for this plus minus 1 or zeros, it's better to use unit circle instead of a special triangle. So let's use a unit circle. Cosine theta represents x coordinates of the unit circle. So when I say cosine theta is negative 1, it means that x coordinate is negative 1. There's only one point that does that. So at this point, I can say that my angle must be pi, half a rotation. Now let's solve cosine theta is equal to 1 over 3. Well, I wish I could solve this triangle, this equation, algebraically, but at the current moment, I have no method of solving this equation without using the calculator because 1 over 3 does not represent any special triangles. So I'm going to use a calculator. Be careful with the calculator, especially when you have a degree and radian mode. In this question, because the domain doesn't specify either to use domain radian or degrees, I'm going to go with the radian mode first. So let's solve arc cos of 1 over 3. And I get the radian of 1.23 approximately. My original cosine theta was positive, which means that my quadrant would be in quadrant 1 and quadrant 4. So let's solve for each quadrant. In quadrant 1, x is equal to pi plus r. Sorry, in quadrant 1 it's just x is equal to r. In quadrant 4, x is equal to 2 pi minus r. So therefore it's just going to be 1.23 in quadrant 1, and in quadrant 4 it's going to be 2 pi minus r. So you also use a calculator. 2 pi minus 1.23. So my angle is approximately 5.05. This question doesn't specify a specific domain or a restriction of the domain. So my angles should be represented in the general form. So let's find um, find the entire answer altogether. So my answer must be x is equal to first 1.23 plus 2 pi n, comma, pi plus 2 pi n, comma, and 5.05 plus 2 pi n. That's theta. So that concludes this question. All right, we'll finish the solution set here. Thank you for listening.